From DataStax, this is the Distributed Data Show podcast.
Hello, everyone, and thank you for joining us for a new episode of this Distributed Data Show. Today, my guest is Mark Paluch from the Spring team. Thank you, Mark, for being with us today. Could you please introduce yourself?
Sure. Thanks for having me, Cedrick. I'm Mark, and I'm working on the Spring Data team. And what I'm doing, that's probably a question that requires a bit more of elaborate. So I'm Spring Data project lead, but I'm also leading the R2DBC project, which stands for Reactive Relational Database Connectivity. I'm also maintaining a Redis driver, the Lattice driver, and because all this is not really exhausting enough, I'm also running a Spring Vault project, which integrates with HashiCorp Vault. And probably you might find me in other areas as well. So I'm doing a lot of stuff because it's fun for me to work in the open source space, to help users to get them started, to help them with their productivity issues, to help develop application development to become even more fun so that you can achieve your job. And this is my passion to work in that area.
Wow. So I heard a lot of Spring project. I know Spring is a galaxy, but with tons of components. But can you give us an overview about what is the Spring framework and what you try to achieve to do with it?
Sure. So Spring is an umbrella for a multitude of projects. So there is a Spring Framework, there's Spring Data, there's Spring Batch, there's Spring Cloud, Spring Boot, and all the things Spring, right? And it all started in the early 2000s, where Java Enterprise developers had a certain issue with how Java Enterprise was supposed to be used. And Rod Johnson back then wrote a book about how he thought Java Enterprise should be used. And based on that idea, the Spring Framework itself emerged. And Spring Framework is an open source library that helps developers with their productivity when they are following Java Enterprise patterns. This is integrating with SQL databases, integrating with Java messaging services, nowadays building web applications, and all these nitty-gritties that you use in your application, you can use them without Spring entirely. But you will have to invest a bit more of time into error handling, resource handling, and all these auxiliary things that every developer and every application has to deal with. And Spring takes all this and encapsulates all these boilerplate things and all these boilerplate tasks, so that you as developer can still use and interact with Java and Java Enterprise APIs, but without really worrying about that boilerplate and common stuff. See, you wouldn't go ahead and write your own connection pool just because you need pooling, but rather you would pick something that provides a connection pooling. Mm-hmm. And this is basically Spring for the Java ecosystem right now. Spring was built in early 2000s and has grown over time. And nowadays, we probably do not talk as much on Java Enterprise APIs as we did the 15 or 20 years ago. Now, today, we talk about Kotlin, we talk about reactive programming, and all the new patterns that have emerged. And this is something where Spring can help you with. And as soon as Spring gets in your way, you can get basically directly to the core of what you are supposed to do.
Yeah, so I can testify. I'm a Java developer myself. I encountered Spring, let's say, maybe more than 10 years ago. And yeah, the minute you touch Spring, there is so much nice features around what you want to do that it really ease the development and speed up. And, even, not only the code is very elegant, but also the way to handling error and error message are pretty well done. So Congrats. And
Thank
so in the Galaxy, you are lead of the Spring Data part. So probably how to interact with all kind of database. So what can it bring?
So the Spring Data story started like 10 years ago, where we figured JDBC is not the only technology how you would like to interact with databases, but rather all the NoSQL stores suddenly started to pop out with their own ideas and their own persistence approaches. And we figured that using a driver is probably okay if you are into the very details of a particular data store. But still you have to deal with all these resource issues, so to allocate connections, to deal with vendor-specific exceptions, and then finally you have to map your persistence strategy onto a particular store. And so we figured, let's see whether we can do something about that. And out of that investigation, Spring Data emerged. The first module in Spring Data itself was Spring Data JPA, which built on top of JPA to make it a bit easier to work with JPA. And the most significant thing that Spring Data brings to you is a consistent set of APIs and concepts that you can find across the board of every single Spring Data module. And if you have worked with Spring Data JPA already, then you might be already familiar with the repository pattern. Repositories are a concept borrowed from domain-driven design, DDD, where you store objects and retrieve objects, and then repository does exactly that for you. You define an entity class or an entity model, you define a repository interface, and out of the box, you get already all your CRUD methods implemented, which are for create, read, update, and delete. And in addition to that, you can declare query methods that are either implemented by deriving from what the method name is. So if you have a method named like find all by first name, then the query that would be generated is using the name parameter to create a filter on that. And we started with JPA and found quickly that this makes a lot of sense, and not only for JPA, but also for a wider number of stores like Cassandra, MongoDB, Redis, Couchbase. There's even a module for LDAP if you want to interact with directory data, right? Yeah. So this is what Spring Data brings you in a nutshell. Besides of that, there are abstractions to deal with resources, with exception translations, so that you get a consistent set of exceptions, and you do not have to distinguish whether this is a Mongo duplicate key exception or whether that's a Cassandra duplicate key exception, but rather you get the same type of exception with all the details attached. And you can find also a common pattern like the template API across all the modules, because that's the ultimate entry point for how you would like to interact with data. If you want to issue a stream query or insert data, delete, or even use store-specific functionality like aggregations with MongoDB. So out of the box with Spring Data, you get the most convenient portion of your data store out of the box by just dropping that library onto your code path and following the Spring Data programming model.
Wow, that's very neat. And when you speak about repository, it's really just an interface. You don't have to provide any implementation. Spring Data does that for you.
Exactly, and this is probably something where folks think, "Whoa, this is magic. How can this be?" And if you work already with Spring a bit, you will see that Spring leverages a lot of JVM features to do its jobs. So for instance, Java proxies to provide you with transaction control, transaction management. So if you provide an interface and say, this is at transactional, then Spring Framework will create a proxy around that and do the transaction orchestration for you. Yeah. And that's a similar idea that is used in Spring Data as well. So you declare that Java repository interface, and Spring Data finds that interface and provides a bean implementation for you out of the box without you being required to write all that code for insert, update, delete, and this for every single permutation of data and data store. But the nice thing here also is, if that's not enough, you can provide a custom implementation and expose that through a repository interface. And you can customize all those repositories at various levels if that's not sufficient what Spring Data provides to you.
Yeah, very nice. And also, under the hood, to initialize the connection and connection pooling, there are multiple ways you can go full convention with only properties and keys for settings, or you can define your own beans, what is a connection, and make that injected in the repositories. That's very neat. So we discussed about Spring Data, and now I would like to dig more into Spring Data Cassandra, because there is a new version there, 3.0.0. So what's new, what changed, and why people should try the new version?
Sure. So let me give you a brief history of the Cassandra module, because it wasn't always in that state how it is today. Spring Data Cassandra was contributed initially by two folks. I think one is from London, the other one from somewhere from New York. In any case, it was a community contribution and a project driven by the community. And at some point, we figured it makes sense to promote that module from a community module to a core module, so that we from the Spring Data team invest more time on that module, help with features that aren't how they should be. And now since I think 2 or 3 years, Spring Data Cassandra is a core module, which basically means that team members from the Spring Data team are actively looking on issues, on feature requests, helping the community with their questions. And that's basically the distinction between community and core module. Now, you mentioned the release 3.0. So it's available since April, I think.
Mm-hmm.
And the big change in comparison to the version 2.2 is that we have switched to DataStax new Cassandra driver. So the generation 2.x was based on the Cassandra driver 3.x, and the Spring Data Cassandra 3.x line is based on the 4.x line of the Cassandra driver. It's probably a bit, numbers. Well, if you have too many of them, then you're confused by those. But you can always add +1 to the major version, and then you hit always the right driver. Probably that's easier to put it. Now, the migration to the new driver was basically a rewrite of the Spring Data Cassandra module, at least from the resource access side, since the Cassandra driver has changed entirely in terms of package structure. There were a lot of concepts that were merged or changed. So one, for instance, is making all the statements and queries immutable, which are shipped by the driver. And this is a great thing, but if your code doesn't expect that, then this is a constant source of bugs. And what we try to do is to design our API in a way that we help users to avoid those bugs, since users are able to specify a query in the same way they were able to do that before. And all the heavy lifting is part of Spring Data Cassandra itself. And besides that coding change that required basically new configuration infrastructure for the session configuration, new implementations for the asynchronous part and for the reactive part, there are a lot of benefits that this driver really provides you with. First is you have a clear separation between statements and queries that are built. Mm-hmm. You can always create a statement from a query object. And you have this pretty neat query builder that helps you with a domain-specific language to create Cassandra queries. And while this was also available in the previous version, there was no clear separation between what's going to be executed and what parts I can reuse. Now, with the current version, everything is thread-safe and immutable. And that really helps a lot. But on our side, on the Spring Data side, there are a few things where we have to dig deeper in that code that is provided by the driver. So Spring Data, writing a Spring Data project or Spring Data code is pretty different from using the driver itself in your application, because in your application, okay, I have this many statements, and you then directly work with the driver. When you write a framework, you have to be sometimes creative about parts, and this creativity isn't necessarily always just complexity, but it also allows to cater for future plans and future enhancements. So one thing we hear quite a lot is, when does Spring Data Cassandra support prepared statements? And with the previous version, how it was written, this was next to impossible, because there was no clear separation between the statements and reusable statements and all those internals. Now, with the rewrite to the next version, and by making things more immutable and thinking more in terms of statement factories, we could already consider that fact, so that we can provide in a future version prepared statement, so that those statements are executed in a more efficient way when working with Cassandra.
Yeah.
So it's not always bad if you have to rewrite things, because you can then revisit some concepts.
Yeah. With prepared statement, you evaluate the statement once, check all the grammar once, and it will speed up your queries. And you mentioned briefly, reactive. If you are implementing R2DBC, you probably also loved the new driver.
Yes, it's great to see that you folks have picked up also on the reactive story, since basically reactive is today what we have seen like 10 years ago with NoSQL stores. Like, everybody is jumping on that same train to evaluate whether reactive makes sense for them or not. And it's great to see that the driver has reactive APIs. We had already in earlier versions an adapter layer that was sitting on top of the asynchronous driver API and exposed the query functionality through a reactive API. And nowadays we are looking with your driver team how we can bring things even more closer together. And that's an ongoing effort.
Yeah, from computation future to Flux. There are a lot of Java folks listening us. That's very promising. I use it, I play with it, and I love it. I love the new version.
Cool. And besides of the driver rewrite, we had also a few other changes that are noteworthy. So first, if you want to upgrade from the previous version to 2.something to 3.something, there's a migration guide in the reference documentation that talks about the changes in Spring Data Cassandra itself. And there you can also find links to the migration guide that tells you how to migrate from the driver version to the new one if you are configuring infrastructure components yourself. And with this change, we also figured that we want to deprecate the XML configuration support. See, if you're a long-time Spring user, you probably started with XML config until you found out that Java config makes actually much more fun. And we found that as well. So we started deprecating the XML configuration. And if you are using XML config, it's always a good time to consider migrating to Java config.
Yeah, I would +1 that. So I'm a very old Java Spring user. I used XML a lot, to tell you, I even implemented namespaces, your own XML stuff. And it's really time to move to Java config, yeah.
It is. Well, XML has still its advantages because you can pre-process that XML in a build step. But I think if you want a more robust system and less surprises, then the Java-based configuration is the way to go.
Yeah.
Then there's another neat feature. So we were asked, I think, 6 years ago, when Spring Data Cassandra was initially built, to provide support for naming strategies. And now, finally, we have support for it. I think this is the oldest ticket that we ever fixed. And now you can plug in your own naming strategy. And this is useful if you want to derive Cassandra column names and table names from your entity model without you having to annotate every single property with a name. Just provide your naming strategy like you would like to see it, and how you want to generate column and table names, and then you go.
Yeah, that would shorter the name of the method as well, probably. Yeah, that's pretty neat.
And what we can also provide now with the migration to the new driver is profile resolution on a per query basis. So sometimes there is a need to run queries with a certain configurations, may it be timeouts, consistency levels, probably
Especially
TTLs.
consistency level. To my point of view, you should make that explicit each time, but just to be sure, you want to write very fast, CL1. You want to have consistency, CL quorum. But yeah, that doesn't.
And in the past, you had to set every single value yourself in query options, and then pass on the query options. And I think that can be tedious to repeat yourself. So what the new driver provides you is that you can associate a statement with a so-called profile. And a profile is just a reference to a configuration set that configures timeouts, consistency level, logging, and a lot of configuration parameters that you can set. And if you have queries that have to run with a certain profile, you can reference that profile in the query options, and then just run it without worrying in the code, which the actual configuration value should be. And this is also a pretty neat outcome of that rewrite. So that we can leverage additional features.
Yeah, it has been externalized as a file, yeah. Right, that's quite a lot of new features to test. Still a lot of going on, I think. Thank you very much for all the details. We will provide the link and migration. We will release a blog post altogether for this new release pretty soon. And okay, again, thank you very much for being with us, Mark. And hope to see you next time, everyone, for another episode of the Distributed Data Show.
Thanks for having me. Bye-bye.
Bye.
Thanks for listening to the Distributed Data Show. Please subscribe with your favorite podcast app, give us a rating, and don't forget to share with your colleagues. Thanks for listening to the Distributed Data Show. Please subscribe with your favorite podcast app, give us a rating, and don't forget to share with your colleagues.